Hello and welcome to another Ginger Mathematician video where I'm going to go through all things algebra for IGCSE, valid for 0580 and 0607. Right, let's get started. So, got a tricky question to start out with. I had a few requests for quadratic simultaneous equations, which this essentially is. So the line y equals x plus 1, so I'm going to underline this, intersects, really important word here, the graph of y equals x squared minus 3x minus 11 at points A and B, and we need to find the coordinates of those points. Now, as soon as I see this word intersects, without really reading too much of the question here, I know from the experience of having the IGCSE course that this means make the two equations equal to each other. So I see that word and that's the first thing that comes to mind. Make these equations equal to each other. Now notice that makes sense because y equals this, so the coordinates where they meet, it will be when those two things are equal. Therefore that means that x squared minus 3x minus 11, so this side is equal to this side, so that's equal to x plus 1. And notice now we have a quadratic equation to solve. So our strategy whenever we're solving quadratic equations is make the right hand side 0. Now how do we do this? We can do this in two steps. I'm going to minus x from both sides to start with. If we do this, well, x squared stays as it is. Minus 3x minus x is minus 4x minus 11, and these x's cancel, leaving us with just 1. Now, of course, you can do this in one step if you so wish, but just to go through what's going on here. And now if I want to make the right-hand side 0, I want to minus 1 from both sides. X squared stays the same, minus 4x stays the same, minus 11 minus 1. Be careful with this, that is minus 12, equal to 0. At this point, we need to do some factorizing, okay? This is the easiest way to solve these equations. So I'm going to set up my brackets and remember the two key rules. I'm going to highlight this. So if we do this a bit later on, you're going to see this in action. So I want two numbers that multiply to give me minus 12, but I want two numbers that add also to minus 4. Now one way you can do this is actually just write out combinations that multiply to give you 12 and then see what works from here. And if we have a quick look at this, if I put a minus here in front of the 6, well, minus 6 times 2 is minus 12, good stuff, and then minus 6 plus 2 is equal to minus 4. So I found the numbers that go into my brackets. This is the easiest way of solving. Try not to go straight to the quadratic formula. Do at least think about trying to factorize. Now, we have two brackets here, and they are equal to 0. So if you have two things multiplied to give you 0, that means either one bracket is 0, so x plus 2 is 0, which then means that x is equal to minus 2. Or, and this is the alternative, the other bracket, x minus 6 is equal to 0, in which case then x is equal to 6. Now at this point, do not celebrate. You do not have all 4 marks at this point. I'm going to put minus 2 and 6 as my x coordinates because we now need to find the y coordinates. Now whenever you have a linear function, so y equals x plus 1, you should really substitute into that. It makes your life easier. So when x is equal to minus 2, y is equal to minus 2 plus 1, and that's equal to minus 1. And then when x is equal to 6, y is equal to 6 plus 1, which then gives me the y coordinates for each point. So our final answer here is minus 2, minus 1, and 6, 7. Again, you can look at the mark scheme and see how we work our way through that. You get 3 marks even if you don't substitute in for y, you'll still get 3 marks out of 4 on this question. Alright, let's look at now quadratics in a slightly different way. And this is quite an interesting question from 0580. So you're given x squared plus 8x plus 10 is equal to this expression. Now you might know this as completing the square, which always drives horror into the hearts of students, completing the square. If you want practice on this, then do check out the video above. I go through this in more detail. Now I'm going to take a slightly different approach to this, and then simply expand out the right hand side. Now remember, x plus p all squared, well that's just the same as x plus p times x plus p. And if we expand this using the double hook, like so. So we multiply everything by everything. X times x is x squared. X times p is xp. P times x is also xp. And then p times p is p squared. If we collect up like terms, which is always important, I have 1 xp, I have another xp, that's 2xp plus p squared. So all we're going to do is copy out this equation, and instead of an x plus p all squared, I'm going to replace it with what I just worked out on the right hand side. So x squared plus 2, well, let's do 2px, we'll see why in a moment, plus p squared, and don't forget the plus q is also there too. And now what we're going to do here is something called equating coefficients. Now, what do I mean by that? Well, I look at the coefficient of x here, which is 8. That has to be the same as the coefficient on the right-hand side, i.e. these two things highlighted must be equal to each other. Notice that intersecting is always coming up, isn't it? So we get 2p is equal to 8, and therefore p must equal then 4. So that's the easy one we can pop over there. And using the same idea here, this 10 must be equal to the constant term, so this p squared plus q. Now we know what p squared is now because p is 4, so 4 squared is 16. So we get 10 is equal to 16 plus q, and therefore we can take 16 from both sides here, giving you q is equal to minus 6 for the 2 marks. So I've taken this approach. Again, you can take different approaches on this kind of question, but I thought equating coefficients is so useful down the line when you do IB or A level. It's a really important skill to see. Now, this is very typical on, this is the paper 4 question here. They now want you to solve this equation. Well, the first thing I notice here is that the left-hand side is same as part A. So notice I can swap over the left-hand side here with the right-hand side. So what I'm going to do now is I'm going to write down x plus, well, I now know what p is, that's 4. And I now know what q is, which is minus 6. And then that's equal to 30. Now I know the temptation here is to use that quadratic formula, and that will work as well, of course. But I want to show you a different method that's a little bit more elegant. So we're going to solve this like a normal equation that we're going to see later in this video. So first of all, minus 6 is irritating me. So what's the opposite of minus 6? Well, that's plus 6 on both sides. This cancels, leaving us with just this bracket. And then 30 plus 6 is 36. Now the squaring is annoying me because I want to get x on its own here. So what's the opposite of squaring? Well, we're going to square root both sides. This is where we have to be a bit careful. So we're going to cancel here, and that leaves us with x plus 4. And remember, the square root of 36 isn't just 6, it's also minus 6 as well. So the square root of 36 is plus minus 6. Because remember, minus 6 times minus 6 is also 36 as well. At this point, we then just treat it like a normal equation. So we have a plus 4 here. So what's the opposite of that? Well, we're going to do minus 4 on both sides. This cancels, leaving us with x. And then we get plus minus 6 minus 4. Now you're probably thinking, how do we work that out? Well, we work it out as two different solutions. So first of all, we're going to pretend it's a positive. So we get 6 minus 4, which is equal to 2. That's our first answer. And then we pretend it's a minus. So we get minus 6 minus 4, which if you don't like negative numbers, you have a calculator, so use it. But we get minus 10 for the second mark. So I've included this question in here because it uses obviously quadratics, but also a different style of questions. So if you're aiming for those higher grades, it really gives you exposure to the style of question they could give you. Again, you can check through the answers and check through all the working I've done in that question. Okay, and on to some worded questions. So you need to make sure you're happy with worded questions. They can pop up in a variety of different forms, and making sure you can translate that language there into equations you can solve. So let's get started. So Gita buys X apples, I'm going to underline this, X plus 7 oranges, and 2X minus 1 bananas. A lot of fruit there. And the total number of pieces of it is 30. And from that, we need to work out how many apples Gita buys. So if we have X apples, If we add the amount of oranges, which is x plus 7, and then we add on the number of bananas, 2x minus 1, that needs to equal 30. So notice, by a quick translation of the question into language we know, we can then get a problem we can solve. At this point, we have 2x here, an x and an x. That's 4x. So 2x plus 1x plus 1x is 4x. 7 minus 1 is equal to plus 6, and that's equal to 30. From there, we use our normal equation solving methods. So we want to get x on its own. The plus 6 is annoying. What's the opposite of plus 6? Well, that's minus 6 on both sides. This cancels, leaving us with 4x. And then 30 minus 6 is 24. You can probably see the answer, but remember the method that we use here. What's the opposite of timesing by 4? That's dividing by 4 on both sides. And that cancels, leaving us with x is equal to 24 divided by 4, and that is 6. Now remember, x itself actually represents the number of apples that are bought by Gita, so 6 here is our answer. Now before I even do the next part of the question, I would just put in here that this is going to be 6 apples. This here is 6 plus 7, which is 13 oranges. And then 6 times 2 minus 1, that's 11, and 11 bananas. So that's going to be useful a bit later on. And substituting in now means we have it ready there for the next question. Now, the cost of 1 apple is 15 cents. The cost of 1 orange is 18 cents. And the total cost is $5.55, also known as 555 cents. And we need the cost of 1 banana. So the way I'd approach this is, well, let's work out the total cost of all the apples. Well, each apple costs 15 cents and there are 6 of them, so we do 15 times 6. Then we add on the total cost of all the oranges. Well, there are 13 oranges at 18 cents, so 18 times 13. And then we've got 11 bananas, but we don't know the cost of it. So we're going to call it 11 times B. So we're going to call B for the cost of 1 banana. And this is equal to 555. So if we simplify this down here, again, a lot of this you can do on your calculator, so don't feel like you have to do this manually. 15 times 6, that's going to be equal to 90. And then we're going to do 18 times 13 here. So 18 times 13 is 234. And then we've got 11 times b, which is just 11b. And then we have 555. Notice the way I've set up the equation here. Once I work out b, that is my answer, and I can just write it down. So if we tidy this up slightly, 234 plus 90, again, use your calculator, don't be shy. So we get 11b plus 324. Notice addition you can swap around, is equal to 555. Then we're going to do exactly the same process as above. Of course, the opposite of adding 324, minusing 324. On both sides, that cancelling here, giving us 11b, and 555 minus 324 is 231. And then we don't like times 11b, so what's the opposite? Divide by 11 on both sides. And if you get a whole number here, that is probably a very good sign. So we get b on the left hand side and we get 21 on the right hand side. If you get a whole number, it's always a good sign. So we're going to pop that in as our answer for 3 marks. Now this question from paper 4 is quite involved, so be aware of that. If they put algebra into a paper 4, there's going to be lots of different skills being tested, so you get lots of really good practice in this video. So here we need to solve this equation here. So 3w over 16 minus 1 is equal to a half. So I'm going to take a mixture of approaches in this case. I'm going to start with the minus 1 being annoying, as it often is when it's just after the variable. So the opposite of minus 1 here is plus 1. On both sides, that gives us, if we cancel here, 3w over 16. And 1 plus a half, well, that's the same as 1 1/2, or 3 over 2. So again, there's a couple of different ways you can approach this. I'm going to write this as an improper fraction, and you're going to see why next. When you have fraction equals fraction, you can do a process called cross multiplying. It's a very useful technique you're going to see in this video as we go through. Now, what do I mean by this? Well, if I times this by this and this by this, you get this cross idea. We can actually simplify this down to an easy equation. Okay, what do I actually mean here? So 3w times 2, that's equal to 6w, and then 16 times 3 is equal to 48. It's a really nifty way of actually removing the fraction very, very quickly. And now we have a nice easy process here. So what's the opposite of timesing by 6? We're going to divide by 6 on both sides. That cancels, giving us w. 48 divided by 6 is equal to 8. Again, use that calculator if you need it. Now, I like this style of question, this AA star element of the question. I look at it and then I think to myself, well, it's almost identical to exactly what I've just been doing. The only difference is, instead of a W, and let's get the highlighter out here, instead of a W here, all they've put is a 2 to the power of minus y. Well, if I know for the first equation that w is equal to 8, in the second equation, what's highlighted here, this 2 to the power of minus y, must also be equal to 8 as well. And this saves you doing a lot of working for a 2-mark question. Now, at this point, to actually work out what y is here, there's a couple of different approaches you can take. I'm going to try and make the right-hand side of this equation look like the left-hand side. So what do I mean by this? Well, 2 to the power of minus y. Well, 8 is the same as 2 cubed. And notice now I've got this base the same. Again, I can raise both sides. This gives me then minus y is equal to 3, and therefore y is minus 3. To really get these top marks at IGCSE, you need to look for elegant ways to get to the answer, because it's going to save you time for those really difficult mensuration, those vector, those differentiation questions right at the end of the paper. And we're not finished with this question, it keeps on going. And now we're into simultaneous equation territory, also a very important skill that I wanted to include in this video. And particularly part 2, where we're mixing a bit of trig in there, is a typical A-star question. Now let's do the standard part here. So when we have simultaneous equations in elimination format, what we want to do is eliminate one of the variables. Now, because we have a plus q and a minus q, because they're different, we're going to add the two equations together. Have faith, it's going to make the equation work and work out p. Now, if we add them together, what happens? Well, 2p plus p is equal to 3p. Q plus minus q, that's just 0, which is really, really helpful. And then 2 plus minus a half, well, if we do 2 minus a half, that's the same as 4 over 2 minus a half, which is equal to 3 over 2. So again, I always like keeping things in fractions, as you've probably noticed in this video, so do keep that in mind. At this point, we can do a little bit of jiggery-pokery, as I like to call it. So I want to get rid of the fraction here, so I'm going to times by 2 on both sides. That gives me 3 times 2 is equal to 6p. This cancels, giving me 3. And that means that p is equal to 3 over 6, or a half. And it's important to leave it as a fraction. You'll see that for part 2 here. So p is equal to a half, or 0.5. At this point, I substitute it back into one of these equations. I'm going to sub in 2, and you'll see why shortly. So p is equal to a half, so we get a half minus q is equal to minus a half. So I'm going to minus a half from both sides. Trying to get that q on its own. It's a tricky one though. This cancels, giving us minus q, and minus a half, be careful here, is equal to minus 1, and therefore q then itself must be equal to 1. So a fairly standard simultaneous equation question. We saw quadratic right at the start of the video, but what leads to is what's really, really tricky here. So hence for the domain of 0 to 360, both for u and v here, we need to solve this equation. And again, it's a very similar idea to what we did in part B, which is it looks almost identical. If you look at the two equations, it looks almost identical. The only difference is that instead of p, we've got a sine u, and instead of q, we have a cos v. You're not expected to just solve this and use some crazy method. You're trying to use what you've done before. So we now know what p is. P is equal to a half. So therefore, sine u is equal to a half, and then cos v is equal to 1. And this is where your trig skills really come to the fore. If you need practice on this next topic, then check out the video above. I go through a lot of trig equations where I use the same ideas as I do just here. Now, the easiest way that we do this is, well, we know what sine is, so what's the opposite of sine? Well, that's inverse sine on both sides. So that cancels, leaving us u is equal to sine inverse of 1 over 2. Now this is where you can't get lazy with this kind of question. So if you do this on the calculator, sine inverse 0.5, you'll get the value of 30. But notice, 30 degrees. But notice there are two values. So use the question here, two values for u. And you're probably thinking, where does that value come from? Well, let's think about what the sine graph looks like. So the sine graph, it goes up like this, and then down, and then down, and then like this. So you need to know this off by heart. It's a really important skill, also later on in your mathematical career. And the peak here is at 90. I think that's all we need for this particular question. Now notice we've worked out, or the calculator has worked out, one of the answers for us. It's worked out this one. So 0.5 and 30. However, there is another answer over on this side, which we have to take into account. Now these black lines are the same. Notice that middle point there is equal to 180. So we also need to get the other answer, do 180 minus 30, which again gives us 150 degrees. Again, I really do encourage you, if you go back a couple of minutes, to check out that video I just mentioned, because this makes a lot more sense once you've seen that video. Now, cos v equals 1 works in the same way. What's the opposite of cosining something? We're going to inverse cosine on both sides. This cancels, leaving us just v. And if we do the inverse cosine of 1, you should get the answer of 0. Again, not the only answer here, because if you think of your cosine graph, let me draw it on the same one with a different colour. It starts at 1, it goes down to 90, down to minus 1 at 180, comes up at 270, and then goes back to 1 again at 360. So you've got two answers here. You've got the 0, which the calculator works out for you, but also the 360 as well. So you need to make sure you put in the 360 degrees to make sure you get all 4 marks for that particular question. And that is the end of that particular question, question 3a. So you can check all the working I've done so far on it. Okay, and on to some more typical algebra skills that we haven't looked at so far in the video. So question 6 here, we need to simplify, and that means collect those like terms. Collect what looks the same. So notice we have a plus a here and a minus 3a, which look the same. So you've got 1a minus 3a, that's going to give us minus 2a. Be really careful with these negative numbers. And then we've got minus 2b plus 7b. What's that going to be? That's not a pun. That's going to be plus 5b. Remember, minus 2 plus 7 equal to plus 5. And here we've got to do expanding and simplifying. Watch out for these negatives as we go through. And we're going to use what I like to call the hook twice here. So what does that mean? Well, 4 times x is equal to 4x. 4 times minus 5 is equal to minus 20. This is where the negative comes in here. So minus 1, think of this as a 1, times 3 is minus 3. And then where all students make the mistake is minus 1 times minus 2x is plus 2x. Be careful on that, because now we're going to collect up like terms. So we have 4x plus 2x, that's equal to 6x. And minus 20 minus 3, be careful negative numbers here, is minus 23. Now another typical skill is using algebraic fractions, and what we're going to do here is write this as a single fraction in its simplest form. Now the easiest way to generate a common denominator, which is what we need here, is just to multiply the two things together. So on the bottom we're going to get, on the bottom, 2x times x minus 5. And to work out the numerators, similar to normal fractions of course, is we're going to times this by this and this by this in order to get the numerator. So if we do this carefully, so 3 times 2x is equal to 6x, and then 7 times x minus 5, well, we can actually expand this out. So 7 times x is 7x, 7 times minus 5 is minus 35. And then once it's simplified, in order to check that you know your negative numbers. I've said this before. So if we do this, 6x minus 7x, that's equal to minus x. Notice we've got two minuses here, and a minus and a minus make a plus. So we're going to have minus x plus 35 all over 2x, open brackets, x minus 5. Again, you can have this the other way around as well. It's absolutely fine. Just be very, very careful with negatives. It's such a common mistake that's made, and through practice, you can avoid making those mistakes yourself. And now we're going to solve this equation, and hopefully you're getting sort of the patterns of the questions at this point in the video. I see a fraction. I don't like fractions. What's the opposite of dividing by 3? We're going to times by 3 on both sides. This cancels, giving us something quite nice, 13 minus 4x. And then we times both of these by 3, so be careful with that. So 6 times 3 is 18, minus x times 3 is minus 3x. Now the way to simplify this really, really quickly is look at the fewest amount of x's. So minus 4 is less than minus 3. And now we want to do the opposite. So what's the opposite of minusing 4x? We want to plus 4x on both sides. Watch the magic happen. So we cancel this out. We're left with just 13. 18 stays as it is. And then minus 3x plus 4x, that's equal to plus x. Notice a lot of the difficulty disappears after that step, and now we can just work out x, because the opposite of adding 18 is minusing 18 on both sides. This cancels, leaving us with just x, and then 13 minus 18, checking your calculator if you're not happy with it, is minus 5. So we pop that in. And there's other parts of the question, because it's a paper 4 question. And this is quite tricky. So this is why it's a 4-mark question. Use the amount of marks in the question to really guide how much work you think is going to be in the question. So make x the subject of the formula. So what this means in normal English is at the end you want x equals something, in terms of not x, basically. Right, how do we do that? So first thing is, I don't like fractions. You're probably getting the hang of that by now. That I don't like it. So what's the opposite of divided by x? We're going to times by x on both sides. Well, x times y is just xy. This disappears. Fantastic. We get 5 lots of p minus 2x. Now the general strategy with these kind of questions with lots of x's in the question is to get everything with x on the left hand side and everything else on the right hand side. So you're going to see that in the next couple of steps here. First of all, we're going to expand the bracket using the hook. That then gives us 5 times p is 5p. 5 times minus 2x is minus 10x. And following that principle, I'm going to put all the x's on the left-hand side. So what's the opposite of minus 10x? Well, we want to add 10x on both sides. Feels like we're not making progress, but do bear with me. So xy plus 10x is equal to, well, this cancels, leaving us with just 5p. And this is where the magic is going to happen. So notice there is a common factor here. They both share an x. So we can factorize into a single bracket. So I'm going to set up my bracket ready and now work backwards. So what do I multiply x by to get xy? Well, just y. What do I multiply x by to get 10x plus 10? And now, notice we've only got one term of x, what we wanted. So now we need to get rid of that y plus 10. So what's the opposite of timesing by y plus 10, well, dividing by y plus 10 on both sides. This cancels, giving us exactly what we want, and we get 5p over y plus 10, giving us all 4 marks. And when you get quicker at these questions, these are quite an easy 4 marks to get. Definitely at the A grade end of the spectrum, but very, very achievable. Right, you can check all the answers that I've gone through in question 6E so far. And now let's move on to some factorising. If you found this video really useful for you so far, then please do subscribe to the channel, because I'm bringing out lots of IGCSE videos, really trying to fill in those gaps for you to make sure you're really ready for those exams. Right, let's look at question 21. So factorise completely 1 minus q minus a plus aq. This is what I like to call a splitting the term factorisation. When you have 4 terms, which are kind of linked in some way. This is kind of the last step of splitting the term if you do this. If you're not familiar with that term, that's absolutely fine. I go through this from the basics. So what I'm going to do is I'm going to separate this down the middle. Like so. You're thinking, what am I up to here? Well, let's have a look. So we've got 1 minus q, left-hand side of that line. And then we've got minus a plus aq. Notice we can factorise that. There is a common factor of a. So I'm going to take out a factor of a. Now notice I take a factor of plus a out. So you'll see that in a moment. What do we multiply a by to get minus a? Well, we get minus 1. What do you multiply a by to get aq? Plus q. And you look at this and go, it's almost the same in both brackets, but not quite. And the way that we can change this, so I wanted to make that mistake on purpose, is if we change this to a minus, then we can just switch the signs and we get exactly what we want in the bracket. Again, if you're not sure about what I'm doing at this particular point, then let's just go backwards. If you do minus a times 1, that's minus a. That's all good. Minus a times minus q is plus aq. So I've just put this into a single bracket, and now the magic is going to happen at this point. Now I put a 1 out here just so you can see what's going on. If we look at this expression, what do they have in common? Well, they have a 1 minus q in common. What's left outside? Well, we have a 1 here and a minus a. We put that into a second bracket. So we get our final answer of 1 minus q, 1 minus a. Now, if that seems like complete wizardry to you, that's absolutely fine. If you see this technique more and more, it gets easier. But if you're not sure with that answer, expand it and see if you get back to the original question. So there's the answer there. Again, you can have it both ways round as well. And I want to continue showing you questions like this. So again, similar idea at this point. We've got 2m plus 3p minus 8km minus 12kp. This kind of question comes up quite often. Again, I'm going to split this down the middle. So we've got our 2m plus 3p. And now I'm going to take a factor out here. I'm going to take out a factor of, well, they have a 4 in common, a minus 4 in common, and they also have a k in common. So I'm going to take that out. And now I'm going to work backwards. So what do I multiply minus 4k by to get minus 8km? Well, I get minus 2m. What do I multiply? Plus 2m, there we are. And what do you multiply minus 4k by to get minus 12kp? Well, 3p. Again, we achieved what we wanted to achieve here, which is that the brackets are exactly the same. So at this point, we take out the common factor of the bracket, so 2m plus 3p. And whatever's left outside, so we've got a 1 here and a minus 4k, that goes in the second bracket. Again, I'll pop the answer over here for you as well. Perfect. Again, expand it if you're not sure if that gets to the same answer as you see in 20A. Now 20B is a kind of different style of question here. It's going to use something called dots, which I'll be explaining in a moment. The first thing, as I always do in looking at these questions, is there a common factor? There is. 5 goes into both. So I'm going to take a factor of 5 out here. What do I multiply 5 to get 5x squared? X squared. What do I multiply 5 by to get minus 20y squared? Minus 4y for y squared. Now I look at the brackets, and we have an x squared, we have 4, which is a square number, and we have a y squared. Bells should be ringing in your brain at this point. If you have all square numbers in a bracket, we want to use the idea of difference of two squares, DOTS. Now, what does that actually mean? Well, it means we can put it into two brackets, and we take the square root of each number. So the square root of x squared is x, the square root of 4 is 2, and the square root of y squared is y. And we put that into both brackets. And in order to remove the cross terms, so when you multiply out the brackets, we make 1 plus and 1 minus. And this is a technique really to recognize more than anything else, and just practice at home so you can answer those kind of questions and get all 3 marks. So you can see the answers there, so make sure you go through that nice and carefully. And yes, we've got some more factorization, because I'm imagining at this point of the video you're still a little bit unsure with this weird factorization. No problem, I'm here to help you. So let's go through this. Again, we look for common factors. So we notice we've got 18 and 27, well 9 goes into both, and a p goes into both. And now we work backwards. So what do we multiply 9p by to get 18px? Well, 2 and x. What do we multiply 9p by to get minus 27p? Well, minus and a 3. So notice all the different varieties of different factorizing questions they can give you. And if you look at question B, hopefully alarm bells are going off. It's one of those. There are 4 terms. They all look kind of similar as well. We need to divide it down the middle. So it's one of those kinds of questions. However, if we try and factorize here, down the middle, notice there isn't a common factor. So this is an even harder question than what we looked at before. So what I'm going to do is I'm going to move this around slightly. I'm going to put an mt minus m. So I'm going to bring the m's together. And then I'm going to put a plus nt minus n. So I'm putting the m's together here, and I'm putting the n's together. And now there's a common factor. When I draw this line down the middle, I can factorize both of them into single brackets. So let's look at the left-hand side. They both have an m in common. And what do we multiply m by to get mt? Well, just t. What do you multiply m by to get minus m? Minus 1. And we get exactly the same on the other side. So have an n as a common factor. What do we multiply m by to get nt? Well, t. What do you multiply m by to get minus n? Well, minus 1. Notice by moving around the terms, which is quite sneaky here, we actually get that form that we're quite used to from previous questions. Notice they have a t minus 1 as a common factor, so we put that as our first bracket. Anything left over, well, m and n go into our second bracket. So we get the answer of t minus 1 and m plus n. Super duper. And you can check the answers very quickly there. And let's look at, again, a slightly different style of question, mixing what we've done with factorizing, but also algebraic fractions as well. So they want us to simplify this particular expression. So the first thing that comes to mind here is, well, can I factorize? That's what I'm always looking at. Can I factorize? Maybe that will help. Well, the top is probably the straightforwardest here because they have an x in common. So let's take a factor of x out. What do you multiply x by to get 5x? Well, 5. What do you multiply x by to get minus x squared? Well, minus x. Okay, that's interesting. And now the bottom is ding, 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 ding. One of those, you've got square numbers. So if we take 25 minus x squared, we can set up the two brackets. And notice we can take the square roots of everything. So the square root of 25 is 5. The square root of x squared is x. And because we want the cross terms to cancel, we put a minus in one and a plus in other. And you really need to spot this on the higher level questions. Now, what's the whole point of doing this process here? Well, you'll see here we've got a common factor, top and bottom, so we can cancel. And we're left with our final answer here of x over 5 plus x. When you see these questions and you know these questions, these are nice, easy 3 marks to get with a bit of practice. Okay, so you can see that you get the final answer there of x over 5 plus x. What I'd really recommend checking out now, because that trigonometry question in the middle was really quite nasty, I would really recommend, so if you really need practice on this, check out the video right in front of you on trig equations, because after that video, that question is going to make a whole lot more sense to you.